The Mathville Marauders have made the finals of their local soccer league. They must play 9 games against their rivals, the Scienceburg Senators. Games can end in either a win, loss, or tie. So if the Mathville Marauders have a 5/8 of a chance to win any given game, a 1/4 of a chance to lose any given game, determine the probability that the Marauders win exactly 4 games and tie either 2 or 3 times. Okay. So, we've got a repeated experiment, the Mathville Marauders playing against the Scienceburg Senators. That's going to be repeated 9 times. That's going to be the number of trials in our question. We have some probabilities here, but notice we have 3 outcomes: win, loss, and tie. So we're going to have to use our multiple outcomes probability formula. Okay, just a quick reminder what that is. N, and then we'll have the various numbers of the various outcomes that we want, and then powers of their associated probabilities. Okay. For us, we'll have an N1, N2, and N3 because we have 3 outcomes: win, loss, tie. And we can already see the probabilities, 5/8 and 1/4, for a couple of these. Okay, win and loss. We know they have to add up to 1, so we'll be able to work out tie in a moment. Now, as for the specific numbers, the N1, the N2, and so on, well, we want them to win 4 games, but the tie, well, there could be 2 ties or 3 ties. And then, correspondingly, we'll have a certain number of losses. Now, this or here makes me think, well, we're going to have to split this up into 2 separate, mutually exclusive events and add them up. Okay, and we know they'll be mutually exclusive because there's no way to tie 2 times and also tie 3 times. Okay, it's the total number of ties. So, here's what we're going to do. The probability we want is the probability of 4 wins and exactly 2 ties, plus the probability of 4 wins and exactly 3 ties. And we'll work out the number of losses in a moment. Okay, so we'll work these out separately using our formula for multiple outcomes in a repeated experiment. And then we'll add them up, and that gives us our probability. Okay. So we'll work on this first situation: 4 wins, 2 ties. Okay. Now it's a total of 9 games that they're playing. 4 and 2 is 6 games accounted for, so we'll need 3 losses. Now, the order of the question, he gave us wins, losses, and ties, so we'll shuffle these numbers around. 4 wins, 3 losses, 2 ties is what we want right now. As for their probabilities, and the probabilities won't change in these various cases, okay, it's 5/8 to win, 1/4 or 2/8 to lose. Okay. And the missing number, lose was second. The missing number, the probability of getting a tie, must be 1 minus the other 2. Okay, because in order to use our formula, the probabilities of all our multiple outcomes have to all add up to 1. So we can trade 1 for 8/8. 8 minus 5 minus 2, 1/8. So even though it's not mentioned in the question, the probability that they tie is going to be 1/8. And that works here as well as in the next case that we're going to have to work out. Okay. So with the N1, N2, N3, the P1, P2, P3, and the N worked out, we can deduce this probability. So it'll be 9, 4 wins, 3 losses, 2 ties. 5/8 to the 4, 1/4 for the losses to the power of 3, and 1/8 to the 2 for the ties. Do make sure you've got the right order for things. Probability needs to line up with the number of times we actually want that particular outcome. Okay, so that's the first one. Now, what about our other situation? Still want exactly 4 wins, but now it's 3 ties. That adds up to 7, so that's going to be 2 losses. Okay, once again, we'll go win, loss, tie, the same order that the question gave to us, although it doesn't really matter. Okay, multinomial notation doesn't actually care about the order of the bottom numbers. So 4 wins, 3 ties, 2 losses now. Same probabilities, though. Okay, and same number of games as well. So 5/8, 1/4 for the losses, 1/8 for the ties. So now it's 9, choose 4, choose 2, choose 3, which is actually the same number we had a moment ago. 9, choose 4, choose 3, choose 2, because multinomials don't care about the order. Okay. But it's important that the numbers match up their probabilities. That's what's going to make this a different probability here. Okay. So there's our other case where the Mathville Marauders win exactly 4 times and tie the Scienceburg Senators exactly 3 times. Because our formulas only work if you know exactly how many times you want each outcome. It can't handle at least, at most, 4 or 5 or 6. Doesn't do that. So in total, combining these two, the probability we want is 9, choose 4, choose 3, choose 2. Okay, we'll get the other one out of the way. 9, choose 4, choose 2, choose 3. 5/8 to the 4. And you could rewrite this a little bit and factor some things out, because both of them will have 5/8 to the power 4. Technically, these coefficients here, these multinomials, are the same number, so they could be factored out. Each one has at least 2 1/4s, at least 2 8ths. Well, at least 2 copies of 1/8, so at least 1/8 squared. So you can do a lot of things, but I would just leave it like this. It shows the formula on display and expresses the answer quite nicely. And the only thing I'm going to do, I'm going to move the plus sign over. I didn't realize I'd have so much space. There we go. There's the probability that the Mathville Marauders win 4 times and tie 2 or 3 times.